Welcome back. Today we're going to discuss the question 18. Induction, proof by induction, mathematical induction for question 18. QCAA External Assessment 2022, Paper 1. Okay, this equation, this is using the Moivre's theorem. So we have a divisibility question. So left-hand side is sum notation. So we will use let's have a look at the n first. So n belongs to positive integer. So therefore n must be greater and equal to 1. So therefore with step 1 we let n equal to 1 to see if the proposition is we need to prove this expression is divisible by 1 plus cis theta. So let's do that. So the expression, I'll call expression equal to, so let's say when equal to 1 means r is an index from n is 1, so it'll be to 3. CIS r theta, so that means we start from 0, CIS 0 plus CIS 1 theta plus CIS 2 theta plus CIS 3 theta, because it's a sum. Okay, this is 1. We know cis 0 is 1 plus cis theta plus this, according to De Moivre's, we know the 2 theta becomes theta to the power of 2. So we can just square, so we put a square outside. This is the we call De Moivre's theorem, same as cis 3 theta become theta cis theta to the power of 3. So now we're going to keep going. So I'll put these two together as 1 plus this theta into a bracket, and plus we know cosine, this is theta square and this is theta cubic, so we can use cis theta square by using square front, become 1 plus cis theta. All right, you can see now we've got a common factor. So we can take this common factor out. Then plus 1 plus cis square theta. All right, so we might call this will call Q theta times by Q theta. So this is so we prove the when n equal to 1, so that's a factor 1, then times by another factor. So therefore, this proposition, so we can prove the reasonableness for the proposition is correct, is true when n equal to 1. All right, now we do step number 2. We assume that n equal to k, the proposition is true, means we call expression is I is the index to the power of 2k plus 1, so that's the end. Then CIS So we might call this is a little q. So we call little q. So now we call ci. This is a r theta. So is true. The expression when k is true means equal to 1 plus. So if it's a statement is true, means we can equal to times by another capital Q theta. So we'll just differentiate between low q and capital Q, lowercase. So that's the assumption. So we're going to use this assumption to do the next step. So when n equal to k plus 1, we also want to do the proposition is true. So the expression becomes from r0 to k plus 1 become 2k plus 3, CRS r theta. So we know we can write down to from r to 0, 2k plus 1, CRS theta, r theta, and plus the other two. So we got two remaining terms. One is another sigma. So the other one is the CRS. So k plus, so 2k plus 2 theta. And the next one is CRS 2k plus 3. So that's the remaining two terms. All right, now we're going to use assumption. This is the assumption of step of number 2. We're going to substitute number 2. So according to the assumption, this guy will be 1 plus CRS theta bracket times by Q theta. Okay, those two I'm going to put into plus CRS theta to the power of 2k plus 1, sorry, 2, and plus, according to de Moivre's, theta to the power of 2k plus 3. So we can see there's a common factor between those two. So I'm going to take the common factor out. So 1 plus CRS theta times by Q theta plus, I'm taking cis theta to the power of 2k plus 2 out, become 1 plus cis theta. All right, now we can see this is the common factor. I can take this common factor out, 1 plus cis theta times by Q theta plus cis 2k plus 2 theta. Bracket. Okay, this bracket I can call, let's call another, so we can say right into CRS theta. These two I can call R theta. So because when n equal to k plus 1, we can also derive this is the factor of the expression. So therefore, the n equal to k plus 1, the proposition is also true. So therefore, we will so therefore the final conclusion is the proposition is true for n equal to positive integer, belongs to positive integer. So that's it. That's the using mathematical induction to prove the reasonableness of this particular divisibility question. So this is a complex familiar, but the only issue is the Moivre theorem to be used. So when you do that, take a little while to do the question. So make sure you have a look at the solution again. And if you like the video, please give us the thumbs up. And also don't forget subscribe to the channel so you don't miss the latest video. Thanks for watching. I'll see you next time. Bye.